But I'll leave you with a bit of food for thought on the finances. I think if you were to take our plans to a contractor, you'd probably be looking at, hey folks, welcome back. It's the Big Barn Build. Today I'm going to be going through a whole host of your questions from the past few videos because I realised I've missed out quite a lot of important info about what on earth we're up to here. So stick around and I'll explain all. So Joe has kindly gone through and found a load of your questions from the past few videos, so apologies if I miss any, but hopefully this will give you a general gist of everything that we've been covering in the past few videos and I haven't explained. So first up, let's give you a bit of a background to what the stage we're at the moment. The stage we're at the moment is we're just about to receive our concrete. It's a nervous few days now as we approach that. We've got a contractor who has been kind of on the scene or kind of coming in for a site visit or two to make sure we're on schedule. We're not, we're actually running behind, and more on that in the actual concrete videos. But we're going to be pouring one slab in one day throughout the whole building. It's 550 square meters to do, 540, 150 mil thick, and that is our structural, our ground-bearing slab throughout the whole building, which partition walls and things like that will be built off. All of the structural walls supporting the roof or the mezzanine already have those little walls in. That's the bit sticking up from the insulation that you see now. So one question we've been getting is, what's the deal with the floor? Why are you doing that now? Well, it kind of has to happen now. We had one option which would have been to try and get the external walls up first, but because we're framing it stick by stick on site, just the two of us, it made more sense to have a nice flat floor to work off. We've also got far better access at the moment, being able to come in and lift power floats in and just generally booming in with a concrete pump off the truck and things like that. So that's why we wanted to do it at this point. But the flip side of that is it's going to be our finished floor. It's a polished concrete floor, and therefore we need to be more careful than we would if it was just a straight up screeded floor and it was going to have insulation and screeds on in the future. So that's why it's taken a lot more thinking, a lot more head scratching to get right at this point, because we haven't got the option in the future to put in tiles and trim over certain areas. We're putting in everything that's going to be visible in the future. So I haven't actually answered a question yet, but there were questions about what's the deal with the underfloor heating and things like that. There is one here. What underfloor heating and house thermostat control are you using? We use Heat Miser in a new extension and it works really well. Don't know is the answer. We haven't looked necessarily into the automation and the thermostats and stuff, but really this is very much one big zone downstairs with the bedrooms over there being separate. So it's less complex than some houses where you might have lots of different rooms and different uses. This is all pretty much free-flowing, and it just lends itself to being much larger zones. We've got Wiser, which is the Drayton controls in the cabin. We're really happy with that. We've had Nest in the past at the old house. Basically, we've still got that time to decide on that. As far as the heating system itself, again, there's been different back and forth with different companies, but it will more than likely be air source heat pump, and it doesn't need to be big. I mean, the heat demand, well, this is definitely a separate video once I've actually educated myself, but the heat demand is low. It's lower than even though the size of it is actually lower overall than a typical modern-ish family home. So we don't have to have, even though it's a big space, we don't have to have a huge unit. Even though we've got three-phase, that opens up more options. It's a case of having a single air source unit there and the plant room, and it's fairly domestic. It's not too commercial, unlike some of the other bits like the ventilation, which we're going to have to cross that bridge when we get to it. The concrete slab is the thermal mass, and that's what's going to, one, have all of our heat reserves in it, because this really low temperature, very low and slow heating system that we're putting in is just going to be very, very flatlined, as far as it's going to be very low to react to anything, which should be good in our lifestyle, at least, heating it basically 24/7. We're not in and out from work and needing the heating to come on an hour before we get back, and those sort of really responsive heating systems. Otherwise, this pipe would need to be much higher in the build-up. So it ends up about 130 millimeters below the finished floor. So we can put the heating on. It's going to take days to actually come through, but once it's there, it's very, very stable. And that will benefit as well with some solar gain and acting as a sort of a buffer, you know, just a big heat sink as well. One of the options was to put this heating pipe clipped to the rebar, to the mesh, and that happens in a lot of self-builds. I just don't like the idea of it. One, it'd be a nightmare to install, but also, even talking to the concrete guy, Nick, he was like, I just probably wouldn't have taken the job because you're treading on the pipes and the pipes are directly on the metal, and I don't know. I'd much rather they're down here. We were, you know, taking our time, getting it all right, and then we can carry on and put our steel above this. You're doing lots to insulate the slab, but aren't your steel's going to be a massive thermal bridge, and how are you tackling that? Yeah, that's a kind of unavoidable. We've intentionally pushed our planning to the limit as far as to do a full application rather than a Class Q, which has meant that we can insulate outside the steels. I believe actually Class Q laws, regulations and stuff changed this year to allow a slight increase in building size for that reason. But we were really, you know, harping on our planning officers and stuff at the time, 2-3 years ago, when we were going through all this, that it didn't make sense for our steels to be sat out in the cold and all the risks there, and it didn't lend itself to being an efficient home. Anyway, we went one step further to a full application. That meant we had a bit more free reign on that, so we've been able to take our insulation around the outside of the steels. So above ground, we are happy that we've wrapped the steel frame, but where they go down into the ground, that is a weak spot. It's an issue. So what we have done is insulated below ground slightly, and as it comes up through the floor, we've got the option to insulate those as like columns, because they are all within walls, all of our steels. Even these new posts over here, there is ways of insulating like on a structural foam or structural pad to give a thermal break, but really that's only where it hits the concrete pad at the bottom. You still got that backfill around it. So we've done the best we can. Basically the bottom 300, 400 mil is fully insulated, and then we've got the option to kind of box it and insulate it above. But I'm going to chat that through with the architect and also building regs, just to make sure we're all good there. But obviously the main thing is condensation risk on the steels. We don't want that to be an issue, but also it might just be one of those things that we are going to lose some heat down through the steels, just these centre ones in the middle of the house, and that's just the nature of the beast. Question was wondering why you laid concrete on the outside of the ICF pool. Remember, the initial plan was to backfill that concrete ICF, not backfill it, sorry, fill the ICF and have that shell of the pool complete, and then we could backfill around the outside. The problem there is, in order to fill the core of the ICF, we need to have all of our plumbing, our skimmers, our pumps and sumps and all that sort of stuff in place. Pool plumbing is not cheap, especially if you're buying the decent stuff. We would have wanted to get it all pressure tested, and the guy who we're dealing with for kind of as a bit of a supplier consultant on the pool stuff would need to come down. He was going to test it and just check over everything. There was just a whole load of things that would have meant we'd had to have pushed to get all that done, then get Steve back because we were going to film the pumping in the ICF and make sure it's all braced before the concrete goes in, before we would even be able to build the last bit of walling around it so we could finish the slab. So that's why we made that decision to backfill before we did the ICF. We had a bit of an issue there, but no huge issue. So that's why we ended up doing that ahead of the pool. Now it means that we can carry on and build the wall between the house and the pool can be done whenever we get to it. It might happen sooner rather than later, or we might just forget it exists over winter and then come back to it next year. We'll go round circle here. Is the heating going to be zoned? The kitchen area will be mighty hot if it's at the same temperature as the rest of the house. It might, but in actual fact, it's such a big volume of space. It's got a 4-metre ceiling, for example, and it's got a 4-metre opening through to the big zone of the living area, because we're not going to be able to afford whatever internal bifolds we're going to go there for a while. So I don't see that as an issue. We could put it on its own zone, but very much, or it will be on its own loop. So there is the option to control it separately, but I imagine we'll be happy with it being one big open plan space. Question here on plastic sheeting. So the plastic sheeting, they got absolutely battered in the storm at the weekend, hence why it's not looking so organised back there, is called scaffold sheeting or protection sheeting. I managed to find it in 3 metre height, which is why we've got it all the way up on the sides. Well, that side blew down, but I hadn't battened it. As soon as the battens are clamping it to the wall, it's pretty solid. As soon as you're relying on just cable ties or tacks or whatever, or staples, for example, it's a no-go. So it's worth, if you're going to put that up, and this side over here, where it looks like a light tent, that's probably going to be up for the whole winter because there is no wall there. That's all going to be glass in the future, but the glass won't be here until January, February. So in theory, that is our only source of natural light in winter. So we want to make sure that's battened well and it's not going to rip and shred. Someone said, would love to see some detail around how you're sealing the foam with expanding foam joints or similar. I assume you mean the slab, because that's the only insulating we've done so far, and in which case we didn't actually use too much expanding foam gun grade stuff, only around the perimeter where there was any slight gaps we did, or if we'd broken a corner of a board and we needed to fix it. All of these, we made sure they were butted tight. We taped them, as you saw in some of the videos, and that was it. As far as if you were fitting them between timbers and things like that, where you might use Gapo tape, you know, we did that in the cabin. But one of my big aims for this build was I do not want to be cutting insulation boards. It is just the worst thing to do. It's not healthy. It's not enjoyable. You know, trying to cut them and scribe them and fit them in between joists, it's a bit antiquated, I think. It just makes a whole lot more sense, where possible, to use if you have to use PIR or a sheet material, stick it on the outside, stick it above the roof, stick it on the outside of the wall, and don't be fitting it between studs. And I've just done so much of it. It was just one of my big aims, was to avoid that. Which is why there's no PIR going anywhere in the walls at all. Yes, it's in the floor, it's all locked up there, and it just made the most sense. I would have used EPS if I could have done the depth, but we couldn't. We had to work with ground levels and things. So we went with 150 PIR. 100 millimeters PIR would have been sufficient. And even building regs were happy with that because of the balance over the whole building. But I pushed it, we went to 150 for the walls, which we'll cover in all the timber framing videos. The framing design would actually allow for us to fill it with sheep's wool, mineral wool, any loose fill insulation. There's lots of options, but I'll talk about how and why and what we've picked to do that, and all the air tightness layers and things like that. But we're jumping ahead there. It's hard to tell from the camera angles, but I hope you left yourself a 9-foot ceiling between the first and second floor. Makes such a difference. And also that they forgot to put a vent in for their fire. So well done for catching that out. So the vent for the fire first is this pipe down here, which you can't see. It's just a 110 pipe sticking up out the insulation. That is just a direct air feed to a fire. And we did it in our very first wood burner at the first house. And it just means you're not sucking warm air from the house. If you've got an airtight build like this will be with MVHR, you're therefore not pulling cold air down the chimney. There's just a million and one reasons why. It just makes more sense. Therefore, we've got that in. It's coming up in, hopefully, around the right place. It will be below the concrete by about 20 mil. We know where it is. We might not do a wood burner in that exact spot for a long time, because a wood burner there needs to be a sizable thing to look right in the space, and none of them are cheap. So we'll just forget it's there. But no, we'll know it's there, if that makes sense. I might even I was saying to Tom, I might put a nut, tape a nut to it, and then we could find it with a metal detector, the cap that we set there, just because it is a little bit lower. All the other drains are set about 3 millimeters-ish below the concrete, so we will know very easily, because we can just tap and break out that bit above. Some of them might just be completely flush. That one we set intentionally lower, so that if it came to it and we never ever had a fire there, our polished concrete would still be fine over the top. And the first part of that question was the height of the ceilings. Good question. In the middle of the house, which is the living area, we've got the ceiling just below this steel. So I'm using 300mm joists, and that's 254 or whatever it is steel. That means that we're going to be 20-25mm low and high in the hangers, which means basically that all of our sheet material on the ceiling can run under nicely. Same with the floor. There's no messing around with extra battens and furring strips and things like that. We've intentionally set everything at 400, and I think that's going to make things more simple and just a good way to go. That will leave us with a 2.4 metre ceiling, which is no big grand high ceiling. It's a conventional ceiling, but we kind of didn't mind that. We wanted that because this will feel hopefully a little bit more domestic and cozy, this area, bearing in mind that I stepped this side of the steel and it's fully vaulted, nearly 6 metre ceiling. So if you imagine having some huge cavernous space everywhere, it would not be ideal. It's a cat. I realise I've brought a fixed focal length lens, so it doesn't really help you with the wide angle, but the kitchen ceiling is going to be getting on for 4 metres down to 2.5. So that's a big void space, as is the garden room, going to be full height vaulted. So there's areas of both, and we've intentionally, in that far corner, which is our lounge, snug sort of lounge, intentionally kept the ceiling flat. We've brought it down, we'll put ceiling timbers in there. It's going to have a timber frame in there. That's going to feel far different from the rest of the building. And the same over in the annex. We just thought, well, we may as well flat ceiling all of that. There'll be a little bit of loft space above, which is where the ventilation plant room will be. And it just means that not everything is vaulted and huge, and you know, it could quite easily feel like a warehouse. Another question, are you putting in rainwater harvesting? Well, I mean, it'd be full after this week. Originally, yes, we were definitely going to do that, and we'd even like spoken with people, and we had things lined up. It doesn't necessarily help us completely, because for our drinking water, we've got mains water here. Joe's really keen to have a borehole. The water here is just tastes like he's drinking out of a swimming pool. But that would become an expensive luxury when we've already got mains here. But it's not like we're having to put in a kilometre of pipe like some barn conversions might have to. That said, we've got a borehole company who are potentially lined up, but it's in that list of sort of luxury items that, while they're not luxury, like copper bath or something, that they are things that are not necessary, a bit like the wood burner. But they all serve a practical purpose. So the wood burner, for example, we have our own woods and trees falling down all the time. We could probably create and produce enough biomass to heat the whole building. I don't want to do that. I've been down the biomass route before. So I think the air source heat pump is good, but actually in real terms, that might do a lot of our heating as it is. If we're always in and we've always got a fire going, you know, that might be a good option. With the borehole, we've got the water already on site, but actually with all the troughs out in the fields and that, you know, irrigation and anything else we're doing out there, plus the use of all the buildings, and it might make sense to have our own supply and a bit more, you know, security as far as on utilities. But do we really need it short term? Probably not. Would we like it? We would. And then if you've already got a borehole, you're not necessarily paying for the water. And if you've got solar for the plant room side of the borehole, I don't know. Do we also need a rainwater harvesting setup as well? I don't know. Maybe I'm ill-informed on that. But why, if you were having a borehole, why would you have rainwater harvesting? What was the yellow plastic for at the end, please? I think that was 2 videos back when there was a little bit of the green plastic going down. This green plastic membrane is just a vapor barrier. You could use the black DPM instead, but that is stopping the concrete from being directly in contact with the foil because they can react. But also, if it's quite a loose, pumpable concrete, or if you're using a liquid screed, then if you don't have this membrane, then you can end up with your insulation floating, because your screed can find gaps and go down and then get underneath. And I mean, that sounds like a nightmare scenario. Luckily, with a concrete pour, you don't really have that risk, but that's the reason why you put this separation membrane down. We ended up going with the clear, greeny vapor barrier instead. It's thick enough, but it also did help that some of our insulation boards had the grid pattern of 100mm grids facing up, and when you're laying the pipes, that worked quite well. I know one comment came up saying you can buy a membrane with the grid pattern on it. Might work if it was a single zone, single room, but where you had so many laps and things like this, I can't imagine you'd line them all up. But any reference like that to go off, even if you've only got 1 or 2 lines to start you off, it was useful to have. So go with a clear if you can. Someone's saying polished concrete floors aren't any cheaper. You're right, you're definitely right. I'm going to do a video on it, because I don't think anyone will actually guess how much we were quoted. Well, you probably might, for a polished concrete floor in here. It was a bit of a shocker. One option originally was to do a 100mm polished concrete screed, and in one design it was put above insulation on top of a structural slab. So why not just put the whole structural slab on top of the insulation and polish that? We're going to do a video very soon, actually. We went down several months ago and met with Sammy, who has done 2 barn conversions in Bristol, and he has done polished concrete floors in both, pretty much DIY job, and really, really nice. He's lived with one for 2 or 3 years, and he showed us that one, and he's just done another, and he learnt a few things along the way. So we filmed with him, and hopefully if I can find all the footage, we'll put together a video just explaining why we're going with... Sorry, someone wanting chickens. That is now dealt with, and I can't remember where we are with our questions. We've got to pour concrete because it's part of our structural, foundations of the building, or it's just a ground bearing slab for our floor. We may as well give it a shot and make it our finished floor, even if we decided 10 years down the time that we wanted to tile it or carpet it or whatever it might be. We've still got that option. So it just needs 1 level of finish more, or 2 levels of finish more than it would if it was just a standard subfloor that you might have if you were going to carry on and put insulation and then another whole screed on top of that, which is what normally happens. So without it being block and beam, it's a ground bearing concrete slab sat on our insulation, fairly conventional. But because we've got a big space, it means we can go to more of a commercial contractor for our finish, for our install, which means they can get ride-on power floats in here, probably 2. So we can lift them on with a telehandler or digger, and they can then go through the finishing process of getting it far smoother. So they're really used to doing factory floors, big corn, wheat stores and grain stores, I should say, on farms, and industrial units and things like that, where it's a really smooth finished floor, but it's not polished, it's just power floated, but power floated properly, really well. So the deal is that they're going to do up to that point, and then the next day we will do all the control cuts, we'll do all the covering and wrapping and preserving, and then further down the line we're going to do the polishing. And when I say polishing, we're not grinding all the aggregate down to do a sort of terrazzo, sort of exposed aggregate floor. We're going to be doing a cream finish, which is more like a fine sanding of a polish on top. We've got a concrete consultant that we found. He's been helping us, and he's going to supply gear and the know-how and maybe a site visit. But even if we pay for those things, even if we bought a machine and then had to sell it again, it would be far, far cheaper than if we were putting down a bog standard concrete floor and then going to B&Q and buying the cheapest tile and putting it in here. Because of the space and the area, even if it costs us £5,000 to £10,000 of machinery, extra paying, I've bought different blades for doing the control cuts. We bought some colouring to put in the colour in the concrete, not in throughout the concrete. It's a colour hardener. Again, future video, future discussion. But even if we do all that, it's still, we would have had to do the concrete anyway. There's only a top up amount of money we're paying to give it a shot. Give it a shot to try and see if we can come up with a finished floor that we're happy with. But it's not the end solution necessarily, because we can always upgrade our floor if we want to. Hopefully we won't want to. Hopefully we'll be astonished. We did have some questions about glazing and the wall and the insulation and more sort of really detailed stuff. I won't go into that just yet, but glazing is a big thing that we really need to hurry up and make a decision on. Most glazing companies that we're working with or getting quotes from are around 12 to 14 weeks lead time without delays. So it could easily be more than that, which means really we could have ordered them months ago, especially because we're going to have to order the windows before we have structural openings. It's all well and good people saying, don't order your windows until your openings are there. That might work if you're using a UPVC window supplier and then come in, measure up, and a week or two later come back with the windows. When it's a 4 month or more, but we've just got to work off plan. So they've got our window schedule, which is all of the sort of glazing structural openings. Tom and I will now have to build our structural openings to that same number, and hopefully a few months down the line those things will line up and we won't have too many issues. But wood being wood, we can always fabricate and shave a bit, but hopefully it's all going to work out. But it is expensive, and I think we kind of put in this worst case scenario of I think £70,000 or something like that, which I never ever would have thought that's what glazing costs when we didn't have a house to build. But you soon learn that that's kind of just what it is when it's that volume of glass. But we've managed to get things down. We've changed more complex windows to fixed units. We've tweaked bits. We've, for instance, here, all the pool glazing we won't do straight away. That will be a staggered thing a year down the line. We've got 2 sets of glass here, so we might leave the outer set for now. There's just lots of decisions we can make to make that a little bit more affordable. Some of them, so they're all alu-clad wood windows, triple glazed, passive house standard stuff. But some of them could be downgraded to a UPVC inside surface, like in the annex, for example. And there's little bits we can work with. But having had 5 quotes now, it's pretty much a level playing field. There's some which are, really chancing it, and then there are some which it's too much of a compromise. If we're going to all this effort, we may as well really push, even if it means the finer details and final finishes we can't do quite as nicely or quite as soon as we might otherwise. But I don't want to glaze it again, and I don't want to build the walls again. I don't want to insulate it again. So that fabric of the house has got to happen now, and we just need to be, a case of pushing ourselves as much as we can to get that bit done, and then work out, what on earth we do after that. So I'm not sure where that leaves us, other than a big task ahead. We've only got a matter of days now to be at a point where this is ready to hand over. There's going to be a team of 8 people, maybe more, and 2 or 3 of us on the day. It's going to be a really action-packed day. I mean, I thought the roof was a big moment, which it was, but this floor going down is going to be, I can't wait, because from a practical point of view, it just means we've got a level surface. You can imagine framing up walls. We have sawhorses in here. We've got something like 1,500 meters of framing material arriving on site. We can just hopefully be really organized about it, have a dedicated workshop area, get it all set up, be really, just far more on top of it than we have. At the moment, tools are sat in the back of a sheep trailer. There's stuff here, there, and everywhere. And obviously the wind is just blowing through. So the sooner we can get these walls up, the better. The aim is to have the walls up and membraned in November, which means that while we won't have an insulated space, it will be relatively windproof, albeit that the patio area might be just sheeted for now. And then that way we can carry on working from the inside, get the mezzanine in, and we might even start looking at getting the insulation into the walls, even though the glazing and stuff won't be there. So the glazing, we'll just have to have a membrane run over it, and we'll leave it boarded. but we're kind of, none of it's conventional. It is what it is. You know me, you know the channel. It's kind of a bit of a unique situation normally where we make stuff up as we go along. And some of the details might not be mainstream, and that's why hopefully it's going to be entertaining to watch. I'm going to leave it there. If I've missed questions, which I probably have, stick them down in the comments and I'll answer them down there. Finances, I know, it's like the big elephant in the room on how much everything's costing, and we're keeping tabs on it. Joe's going to do a big video on it soon, a bit like we did on the cabin, sharing on how much things are costing. But I'll leave you with a bit of food for thought on the finances. I think if you were to take our plans to a contractor, you'd probably be looking at 1.5 million to do it, just because of the square meterage. But this is not like a conventional house. It's so much different that you can't use any rule of thumb type equation. It's not a case of £2,000 a square metre, £2,500 a square metre, whatever it might be, just because there's so many open plan spaces with not much more than a polished concrete slab and a roof. So it doesn't work in quite the same way, but we have no way near whatever that high-end figure would be. We're just working through it. If we can get to the point where we've got the shell insulated, glazing in, and then we've got a year or two to work through the inside just on what we can afford and as and when, then I'll be happy. If we can get the main structure up within budget, that's the main plan. But that is for a separate video, because I'm not even sure what the budget is yet, but it's not much. Think cabin spec, but just a bigger cowshed version. Anyway, I'm going to leave it there. Like I said, any questions, leave them down in the comment section below. And I'm going to go and have a coffee. Thanks for watching. Remember, if you can, do it yourself, and we'll see you next time.